Hi, hello. Welcome to my session on electromeric effects. After the inductive and hyperconjugation effects, in this session, in the previous session I discussed about that hyperconjugation and inductive effect. Now in this session, I'd like to discuss about the electromeric effect. Okay, and followed by resonance and mesomeric effects also. Okay, let us start the discussion. Actually, what do you mean by this electromeric effect? What is electromeric effect? Electromeric effect is nothing but in the presence of an attacking reagent, an attacking reagent, there is complete transfer. There is complete transfer of pi electrons from one atom to other to produce temporary polarity. Temporary polarity on atoms joined by multiple bonds. It is called electromeric effect. Electromeric effect. Once again, the definition is very, very important. It is the presence of an attacking reagent. There is complete transfer of pi electrons from one atom to other to produce temporary polarity on atoms joined by multiple bonds. That is called electromeric effect definition. Now we will see a chemical interpretation here, equation generalization. That is, if two carbon atoms joined by a double bond like this unsaturation, if we have observed the electrophile which is added, suppose electrophile added, we have added electrophile, what will happen means that double bond will become single bond between the carbon atoms, and one will take the electrophile, one carbon will become negative, another one will become positive. Once this electrophile is removed, if you see the backward direction of the reaction, again we will get the original one. That means the reason why we are calling this effect is temporary effect. So this effect is temporary and takes place only in the presence of reagent. In the presence of reagent. So what we will understand here is, as soon as the reagent is removed, as soon as the reagent is removed, the molecule revert back, the molecule reverts back to its original position, to its original position. Okay, this is the point to be noticed here. That means we are seeing electromeric effect is temporary effect. The reason is nothing but once the electrophile removed, what will happen? You have noticed that is nothing but original molecule will be obtained. That means it is a reversible observation process. In this electromeric effect of two types is there. It is positive electromeric effect, negative electromeric effect. What is the types here? Positive electromeric effect, negative electromeric effect. Two things are there. That we will discuss about the positive electromeric effect. E plus E stands for positive electromeric effect. Minus E stands for, here in this discussion, it is called as negative electromeric effect. Negative electromeric effect. Now let us see that first one, that is positive electromeric effect. Positive electromeric effect. See, we have discussed that pi electrons are important in the discussion in the electromeric effect. What happens when pi electrons transfer takes place between the carbon atoms? That is denoted by positive effect. That means, what is positive electromeric effect? When pi electrons transfer takes place carbon to carbon. As we know that as in alkenes, also we observed that alkynes, in alkynes, etc., this is possible. So that is called as positive electromeric effect. Positive electromeric effect. As you know, it is denoted with a symbol denoted by plus E. Okay. So that one we will see, that is if we have a carbon-carbon double bond is there. Like, yeah, H2C double bond CH2 if you write. If we are adding electrophile, that means electrophile added. Suppose electrophile added to this one. What will happen? One carbon will get positive charge, other one will get negative charge. Suppose if you see the reverse direction, when electrophile removed, and the electrophile removed, again we will get the original product compound, that is nothing but alkane. Okay, that is the thing. Similarly, when we have a 3 carbon chain is there, like CH3, CH double bond, CH2 is there. Here what happens when we have added electrophile, that means electrophile is added. You'll get CH3, CH, this is plus, the other one is minus. Okay. So if you see the reverse direction of the same reaction, if the electrophile is removed, you will get the original starting product. So we'll see that with an example now. For example, addition of acids to alkenes, if you see. Addition of acids to alkenes. Okay, what happens? We will take an alkene here, like this. Carbon-carbon double bond we will take. Acid means H plus, H plus. This is electrophile. What happens? One of the electron pair here, pi electrons shift towards one carbon. Then one carbon will become positive. On the negative charged carbon, the electrophile takes place. That is called as plus E effect. So in this, there is also a positive inductive effect of methyl group. Earlier what we have shown, methyl group, which causes pi electron transfer from the carbon to carbon, also possibilities that we'll see that. Okay. Now we will have one more, that is when we have a CH3 is there, it is electron releasing group, like I shown here above. CH double bond CH2 is there. So what will happen if this is in turn attached to another group, this unsaturation, suppose a CH2 CH3 is there, is CH5 only. Then here both sides of the double bond we have alkyl groups attached. So these alkyl groups, if you start observing the numbering also, okay, Then on the second carbon, this is the second carbon we have, the pair of electrons will be transferred. So here what will happens? The ethyl group is larger than that of methyl, hence pi electron transfer is taking place from this C3 to C2. This is third carbon in this one. So what we have understand here is and the positive inductive effect, electron pair shifting towards a carbon, towards that carbon only, to that carbon only this electrophile will be attached. That is called as a positive inductive effect. Positive inductive effect. Now we will see negative electromeric effect. What is the definition of it is nothing but when pi electrons transfer takes place, when pi electrons transfer takes place, okay, that transfer takes place to more electronegative atom, more electronegative atom. You know more electronegative atoms like oxygen, nitrogen, sulfur, etc. That more electronegative atom joined by multiple bonds. As we all know that these oxygen, nitrogen, sulfur capability of forming double bonds with other atoms also like carbon. In such a case, what happens between carbon and these atoms, the electron transfer takes place. The transfer towards this type of atoms as they are electronegative. What is the thing is nothing but when the pi electrons transfer takes place to more electronegative atom joined by multiple bonds, then that is called as negative electromeric effect. Negative electromeric effect. Now we'll see that negative electromeric effect in the case of carbon oxygen. See, we have carbon oxygen double bond is a suppose. We have added an electrophile. Then this pair of electrons will shift towards oxygen only. Then carbon will become positive, oxygen will become negative. Once the electrophile is removed, as usual, you will get carbon oxygen double bond. Okay. Similarly, if you just see the carbon nitrogen triple bond is there in some organic functional groups, then carbon nitrogen triple bond in that pi electron shifts towards the nitrogen and double bond will be formed. Nitrogen will get negative, carbon will get positive. When we have added the electrophile, we remove the electrophile in a reverse reaction, what happens? Definitely we will get the CN functional group. So removal is one thing that is possible as it is a temporary effect. So this can be understand by using an example. For example, what is the point here to be discussed in the electrophile is the addition of cyanide. Example I will take the addition of cyanide ion, I will take ion to the carbonyl group. The carbonyl group. That example you will see. That is in the case I will have another color, that is carbon oxygen double bonding carbonyl compounds is there, and we are adding cyanide Cn minus. Okay, in that case, if you see, carbon oxygen double bond will become single bond, and Cn minus is there. That Cn minus will attack on positive carbon. Oxygen remains as negative. Okay. Here, if you carefully observe the shift of pair of electrons towards oxygen will be there. At that time, the cyanide will come onto the carbon. So here, electrophile case is there, right? Electrophile, if you add, then that will attach to oxygen, not carbon. Not carbon. That means shift is towards oxygen and the group is attached to carbon in this case. Okay. That is the thing we have discussed. That means electron transfer takes place. But when you are talking about Cn minus is a group, and that group, in that group, what will happens? Negative charge is there, that is attacking on the carbon. So this transfer is taking place towards the oxygen, and the group is attacking away from that group, electron transfer. So electrons are transferring to another atom, and group is attached to the other group. That means different opposite directions they are taking place. But in the positive electromeric effect, what happened? Electrons transfer towards one atom, towards that only electrophile attacked. So here this is, we will call it as minus E effect. Once again, I'll read what is negative electromeric effect. Negative electromeric effect is nothing but when a pi electrons transfer takes place to more electronegative atom joined by multiple bonds, then that is negative electromeric effect. So this kind of shift towards the more electronegative atom is called as negative electromeric effect. Here we observed the cyanide ion attack example. Okay. So what we have understand is nothing but electromeric effect is represented with letter capital E, and it is of positive electromeric effect and negative electromeric effect. Two things are we have noticed, positive and negative electromeric effect. What is positive electromeric effect? And the positive is nothing but displacement of electrons pair always away from the atom or group. Positive, we have to show, we have to understand one thing, that is displacement of electron pair is away from the atom. away from the atom or group takes place. What is the negative one is the displacement towards the atom or group takes place. In negative, that is displacement is towards the atom or the group takes place. So once again I'll give a clarity what is plus E effect. That is if you have a X is a group attached to a double bonded carbon like this, and that is present in that if this is pair is transferred towards one carbon, the pair present over the X will be displaced towards this place. That means between carbon and X. So here displacement is away from atom X. What we understand here is this is nothing but displacement away from atom X. Got it? Likewise, what is the negative effect in another way of our observation? That is, if a group Y is present, the double bond with the carbon, in turn that carbon is linked with another carbon like this, then this pi electrons in the carbon chain are shifting like this. As you know, Y will get negative charge and all these things. That means here displacement is towards Y is taking place. Displacement towards Y take place. So this is the another way of observation. That means again, like inductive effect, what we noticed is electromeric effect takes place only at the requirement of atomic attacking reagent. It always facilitates the reaction, never inhibits it. Okay, so this is a quite interesting thing we have observed. Not only this one, in this we have noticed that quite interesting things in the electromeric effect. A attacking reagent is required, and the demand of attacking reagent only this displacement takes place towards the group, away from the group. So away from the group is nothing but away from this type of atoms is nothing but this is positive electromeric effect. Towards this atoms is nothing but negative electromeric effect. So we have shown the carbonyl group and cyanates, the same thing will take place. So in this, what we have noticed is nothing but this attacking reagent is there, always facilitates the reaction and never inhibit it. So the electromeric effect is common occurrence during addition of polar reagents to carbon-carbon double bonds, carbon-carbon, carbon-oxygen double bonds in a chemical reaction. So in the chemical reactions only, we can understand that whether the electromeric effect is positive or negative. So we can tell positive and negative electromeric effects, we can classify and we can identify depending on the chemical reaction mechanism. Okay, so we have discussed the electromeric effect in this session. Electromeric effect broadly we have identified. So what is electromeric effect? It's a temporary displacement of electrons taking place in a compound containing multiple bonds. So there are alkenes, alkynes and cyanates also there, and with a lone pair of electrons adjacent to the covalent bond. So even the displacement is taking place, but in the last two examples what we observed is lone pair of electrons also undergoes delocalization on the demand of attacking reagent. After that, we told what is the polar reagent, and when the polar reagent is coming towards this type of unsaturations, multiple bonds, this positive and negative and electromeric effects can be noticed. Okay, this is what we have discussed in this session, and we'll discuss further things in next session. Until, have a nice day.